Has Perseverance found signs of life on Mars? Webb scans TRAPPIST-1e for signs of an atmosphere. 3i Atlas grows a tail and could get a mission. And on Spacebites Plus, Webb sees a cloud of methane around the dwarf planet Makemake. All this and more in this week's Spacebites. Wait, it's not Friday? Yes! You are seeing this week's episode of Space Bites early, and that is because we've got an important piece of breaking news and we figured we'd want to jump on it before all the AI slop stories start filling up your feed and it's all very confusing. The big announcement is that there is a new paper that came out this week in the journal Nature that says a possible sign of biosignature found on Mars by the Perseverance rover. Now, this is a story that we have been tracking and following for about a year now, when the Perseverance rover found this really cool rock on the surface of Mars. It looks like a piece of sedimentary rock where you've got this silt and clay that is hardened, and then these little nodules that look like leopard spots inside the rock. And when this rock was first discovered, scientists were already pretty excited by it because you've got these little concentrations of iron in those nodules. And now we've got a new paper that is making the case that this is evidence of some kind of past life on Mars. Now, not current life on Mars. We're not seeing bacteria. We're not seeing fossils, but the presence of the chemicals in this rock could be indicated by life. Now, the chemicals that are really important are two types of rock. One is called vivianite and the other is called greigite. And now vivianite is often found here on Earth in sediments. It's exactly the same thing where you've got clay and silt and you get this sedimentary material, and then you've got colonies of bacteria inside these sedimentary layers. And places like peat bogs, decaying organic matter, and you get this release of these iron compounds produced by the bacteria as they interact with their environment. The other chemical, the greigite, can also be produced as a result of bacteria. But like most of the chemicals that we've seen out there, whenever there is a biosignature, there is an abiotic explanation for how you could get that. That cows burp methane, volcanoes burp methane. And so which is it? In this case, you can have conditions where you can get these minerals forming without the presence of life. But it needs to be in a very high pressure, high temperature environment, often very acidic, a lot of conditions that are not conducive to life. And the good news is that there's a lot of rocks around this specific sediment stripe that indicates that it wasn't in the presence of these high temperature, acidic, high temperature conditions, meaning that for the ways that we know these chemicals are formed on Earth in abiotic conditions, this is probably not one of them. So is it proof of life? No. But it sure is interesting. And what's great is that the Perseverance rover has actually collected a sample, and it's one of the 27 cores that are currently sitting inside, ready to hand over all of these samples to an upcoming Mars sample return mission. And there is the rub. Under the current White House administration, they have canceled the future Mars sample return mission. And the only way to get really conclusive evidence of whether or not this is produced by life or not is to bring those samples home to study them in the gigantic labs that we have here on Earth. Perseverance could just only do so much with the instruments that it has on hand. And of course, the Chinese are planning to send their Mars sample return mission in just a couple of years. And it makes sense that maybe they would choose to go to that exact same rock because it is probably one of the most fascinating rocks that have ever been seen on the surface of Mars so far, the most promising evidence that there could be life. So you're going to see a lot of speculation coming out over the next couple of days, weeks, months, years. Is this proof of life? No, life has not been found on Mars. We've been through this before. Remember the Viking experiments. Remember the discovery of methane on Mars. Remember the Allen Hills meteorite. This happens on a regular basis, and everybody gets very excited. And then, as more evidence accumulates, you realize that it wasn't life after all.
First time?
Yeah, you?
No, not my first time.
But this is exactly the kind of material that the Perseverance was built to search for, to find evidence that there were the conditions for life on Mars for long periods of time, that there are the kinds of organic molecules that you would expect to see on Mars. And so this is the beginning of a mystery. But we can't resolve the mystery without taking the next step, which is to send the Mars sample return mission. So we will keep you posted. Of course, there's going to be a lot of people skeptically viewing this discovery. And then, of course, we'll keep you up to date on what's happening with the Mars sample return mission and the Chinese sample return mission. And then we got another big story this week. And that is that James Webb has moved on and analyzed the next planet in the TRAPPIST-1 system. It was actually just a couple of weeks ago that we got analysis of TRAPPIST-1d, which is the third planet in the system and the one that is just inside the habitable zone of the TRAPPIST-1 system. In TRAPPIST-1d, no evidence of an atmosphere. And so now we've got the analysis of TRAPPIST-1e, and the answer is inconclusive. It was hoped that this world, TRAPPIST-1e, which is now firmly in the habitable zone around the TRAPPIST-1 system, would be far enough away from the star that you would be able to get some kind of conclusive evidence of an atmosphere, that it was far enough away from the solar flares that it would be able to withstand and hold on to an atmosphere. James Webb was able to watch 4 transits of TRAPPIST-1e as it passed in front of the star, and from that was able to measure the planet compared to the star. So what did it find? The preliminary data indicates that there was no primary atmosphere around the planet, but there's a hint of a secondary atmosphere. In other words, that whatever atmosphere the planet formed with, that was stripped away by the solar flares, but that it might have formed some kind of secondary atmosphere after the fact. And in fact, that's what happened here on Earth. It wasn't that we have the atmosphere that we formed with, that was blown away. It's that outgassing and the delivery of various comets and asteroids and so on after the fact helped build up the atmosphere on Earth. It's not dominated by carbon dioxide, which is something like an exovenus, but there could be a hint of methane and partial pressure of nitrogen. So where do we stand? This is inconclusive. If you talk to exoplanetary scientists and say, okay, well, did it find an atmosphere around TRAPPIST-1e? Their answer is too soon to tell. It did not confirm no atmosphere. There was not a detection of no atmosphere, but it also didn't detect an atmosphere with the level of certainty that you would want. But because this is such an important planet, the director's discretionary time for James Webb is going to be applied on TRAPPIST-1e for 15 more transits. And the scientists have developed a new technique that they think is going to be able to better distinguish the atmosphere of the planet from all of the pollution that's happening from the changes in brightness on the star as the planet is passing in front. So unfortunately, we don't have this place where we know what the atmosphere is. It's that astronomers are able to start marking off some of the possibilities to know that the atmosphere isn't. And eventually, we'll either get a positive confirmation of what is there, or they'll be able to rule out everything. One way or the other, we will find out an answer. Like, what I really like about this is that it's about astronomers adapting both their understanding and their observations, but also their technique. When James Webb was built, they understood what its capabilities were on paper, but now we've got it attempting to hone its technique, looking at the best planetary system that we can possibly study for this using James Webb, and it's turning out to be more difficult than they thought. But the astronomers are compensating and coming up with better techniques to make these problems go away bit by bit. And it is this lengthy, complicated process to get better and better. And we're watching this journey unfold. And that's why we didn't get a conclusive answer so far. It's because the astronomers are learning as they go to use this new tool to observe atmospheres in a way that we've never been able to do before. So it just takes time. We got to be patient. And if you want more of the details, you can read this article by Evan Goff on Universe Today. Now, we've been reporting on Comet 3i Atlas pretty much every single week since its discovery in early July. And one of the big things that have been missing so far is the tail. And we've seen a lot of people making claims that it's a very unusual object because it doesn't seem to have a tail. It has a coma, but it doesn't have that tail that comets get as they are getting increased light pressure and solar wind influence from the sun. Well, the tail is here. We've got some new images from the Gemini South Observatory, which is one of the largest telescopes on the planet, 8.1 meter telescope. And on August 27th, it took this picture of Comet 3I Atlas. And what do you know? A tail. And this is exactly what you would expect to see. As the comet is getting closer and closer to the sun, it's experiencing more radiation pressure, it's experiencing more of the solar wind, and this is causing the particles that are in the coma to start to trail away from the sun and point away from the sun. And now we're going to watch over the rest of its trajectory as it gets closer and closer to the sun, as the tail gets bigger. Unfortunately, it's going to go behind the sun when it's at its closest point, and we won't be able to observe it from Earth, but hopefully there's going to be other ways that we can still observe it. And of course, what's exciting about having this tail is that a lot of the chemicals that are in the comet are now stretched out into the tail. And so telescopes can observe the tail and start to get a better understanding of the chemical fingerprint of this comet, which we already know is kind of weird because, of course, it didn't form in the solar system. It came from somewhere else. And so wherever the star system is, whatever the chemicals that were present in whatever abundances in that solar system, we're seeing that in the comet. And it's teaching us about how similar or different other star systems are to the solar system. Of course, you're going to want more details and look at the picture and a lot of other pictures, so check out this story from Evan Goff. But now we have 3 interstellar objects that are currently moving through the solar system. We've got Oumuamua, we've got Borisov, and now we've got 3I Atlas, but these are all seen far away from our telescopes. They're nothing but dots, or I guess big dots with a coma and a tail, but that's not enough information. We want to see close-up images. Like, look at the images that we got from the Rosetta mission of Comet 67P. Let's get that. But the problem is that these objects are moving incredibly fast, especially 3I Atlas. It is hurtling through the solar system. And while it would be incredibly difficult to actually catch up to one of these objects and go into orbit and collect a sample and bring it home to Earth, you can do a flyby and you don't need very much energy. So a team at the Southwest Research Institute have been working on a new mission for doing a flyby of an interstellar object. It's called the Interstellar Object Explorer. And they actually released a paper back in 2024, which we reported on Universe Today. I don't know if we covered it here in Space Bites. Anyway, the minds behind this include Alan Stern, who is the principal investigator of the New Horizons spacecraft. So he thinks a lot about getting very far, going very fast, and observing objects as you do a flyby. And they've calculated that you actually don't need a lot of energy to put a spacecraft into an interception trajectory, where you do a head-on flyby of an object like 3I Atlas and take detailed images of the surface of this object as you hurtle past and as it hurtles past you. Now, who knows if there's going to be enough time to put a spacecraft together to be able to go after 3I Atlas, but now with the Vera Rubin telescope coming online, we should find 6 to 12 interstellar objects every single year, each of which is a chance to study the environment of an entirely different star system. And so you can imagine us building a factory of these things, going after different interstellar objects as the universe is literally revealing its secrets to us, one interstellar object at a time. And you'll probably want to read the story by Matt Williams. And I'm actually going to be interviewing Alan Stern about this mission, so stay tuned for that. All right, let's move out in the solar system to Jupiter. Last week, we talked about the auroras that can be seen on Jupiter around the polar regions. And these are caused by its incredibly powerful magnetosphere. But this magnetosphere interacts with the 4 Galilean moons, and they then leave a signature in the atmosphere of Jupiter that can be seen through the auroras, that as the various moons are passing through the magnetosphere of Jupiter, there is this signature in the auroras that matches it. And scientists have found the signatures for Io and Europa and Ganymede, but they've never been able to see it for Callisto. Well, now they have, thanks to observations of the Juno spacecraft, which is doing flybys of Jupiter. It's done enough observations that astronomers were able to look at the auroras, look at the movements of the auroras, and detect the presence of Callisto's movement through the magnetosphere and how it influences the shape of the auroras on the surface of Jupiter. And just another reminder that the Juno spacecraft is one of the perfectly operational spacecraft that is due for shutdown in about a month from now. So if you want to learn more about this discovery, check out this story from Matt Williams. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week was, of course, the presence of carbon dioxide in the coma of Comet 3i Atlas. So thank you everybody who voted for that. Now we're going to put the vote for this week's show into the post tab on our YouTube channel. So go ahead, just take a second, go to the post tab, vote, or if you're just scrolling on YouTube, vote. Of course, the best chance, subscribe to the channel, click on the notifications bell, and then just vote on everything that you see, and eventually our votes will show up. All hail the algorithm. Yeah, this one's going to be really tricky. I wonder what you're all going to pick. There are 3 stories that are equally important. Good luck. Some of the brightest events in the universe are gamma ray bursts. This is where you can have a single point source that appears to outshine the rest of its galaxy. These are very, very bright. And a gamma ray burst millions of light years away can influence the atmosphere of the Earth. There's like a ludicrous amount of energy in these gamma ray bursts. And we now know that there are different kinds of gamma ray bursts. Some are caused when neutron stars collide. Others are caused by collapsars. These are giant stars that run out of fuel and implode and will create this collimated beam of gamma radiation that goes out into space. But now astronomers have found a very unusual type of gamma ray burst. Instead of one big, bright, short-lived gamma ray burst, they found something that was producing echoes of the gamma ray burst 3 times over the course of an entire day. So that's about 100 to 1,000 times longer than a normal gamma ray burst would last. So what's causing it? Well, the astronomers don't know. And this is one of those examples where you just start ruling out things that could cause it. Can't be colliding neutron stars. Can't be a collapsar. Can't really be a star being consumed by a regular black hole. One possible explanation is a tidal disruption event where you have a star that gets too close to a supermassive black hole and starts to get torn apart. And then that might generate a flash of gamma radiation as it's passing through this accretion disk. But this is great. Like it's an event, it's something bright. We don't know what caused it. The object was discovered by the Fermi Gamma Ray Telescope. And one interesting clue, in addition, was that it seems to be signs of X-ray transmissions coming from this object a little before it went full gamma ray burst. So this one is just straight up mystery. We don't know what it is. Let that marinate. We've got a story by Evan Goff. One of the missions that I am most excited for is the Titan Dragonfly. In 2028, a nuclear-powered helicopter is going to fly to Titan. And a few years later, it's going to arrive, pass into the atmosphere, and fly around examining the surface of this completely alien world and sending home the pictures. And we've been getting regular updates from NASA on the state of the construction of the Titan Dragonfly. So we got a big progress update this week. For example, they've tested the rotors in Titan-like conditions in a wind tunnel. They essentially put the kinds of gases that are present in Titan's atmosphere and then ran these rotors for about a month. They tested out the mass spectrometer that has been customized for the Titan Dragonfly, which will scan and analyze the surface of Titan. They've tested its thermal insulation, which is designed to keep the spacecraft warm in this incredibly cold temperature. It has a very thick atmosphere, and so there's a lot of chance for the cold to get in and ruin the electronics on Titan Dragonfly, but they've come up with an insulation system designed to protect it. And they're testing out the aeroshell, which will allow it to plunge straight into the atmosphere of Titan and then deploy its parachute and get down close enough to the surface so that it can actually just start flying on its own. So a lot of pieces are coming together and everything is still on track to launch in 2028. And of course, I like to end these episodes with a really cool picture. And this one is of the star cluster Pozdnyakov. This is a star forming region. It's about 5,000 light years away. And this image is focusing in on one specific star, which is Pozdnyakov-1. And for a while, astronomers thought that this might be the most massive star that ever been seen. We now know that it's not a single star, but it's actually a binary star system. One of the stars has 74 times the mass of the sun. The other one has 66 times the mass of the sun, and they're orbiting around each other. And this structure in the Pismis-24 cluster should look very familiar to you. It's very similar to what you see in the Pillars of Creation. You've got this star system that's enshrouded by gas and dust, but then the collective radiation pressure from all of the young stars that are in the area are blasting it with its radiation that creates this giant pillar like a smoke trail coming off of the stars. Eventually, the stars will shine with enough radiation to clear out the remaining material. But it's a great picture, taken by James Webb, and I just had to share it. We've got more detailed information about it from Evan Goff. Now, you're watching this week's Space Bites, and I'm sure you're wishing that there was more news, which you can get more stories. Why don't we make these twice as long? Well, we don't have time or budget, but we are covering many more stories on Universe Today in text form, which is the heart of all of our journalism. For example, a young exoplanet is warping the disk around Fomalhaut. An exoplanet in a ring gap shows how protoplanets can shape their environment and how life on Earth probably got some help from space. Now, I send out my newsletter every Friday. It contains all of the stories that we're working on for Universe Today. It's completely free. There's no ads. You can subscribe, go to universetoday.com/newsletter to sign up. And if you do want one more story in this video format, we actually have a longer version of this video called Space Bites Plus. It's available over on Patreon, but it's completely free. There's no ads. You can just click right now, go over there, watch that version, and then do that every week. And this week's bonus story is all about how James Webb has found a cloud of methane around the dwarf planet Makemake. I'll put a link in the show notes. You can go check that out. I'm going to talk about the strange media environment that we find ourselves in this time of some really interesting science news. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Barry Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Balak, Cy Nelson, David Veriboff, David Gilton, David Matz, Evan Pro, Greg Feely, Hudson Ward, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Spitz, Michael Purcell, Monzo, Paul Robach, Brent Kaidu, Richard Williams, Sean Sargent, Stephen Fowler-Munley, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So it's funny, when I heard the potential discovery of evidence of past life on the surface of Mars, my first instinct wasn't woohoo, which is what it should be. It was dread, because I was sort of imagining how this story is going to get out of control very quickly. You know, like, I know I've been on a rant here about the level of AI slop that's showing up here on YouTube, but this is the situation where you've got a nugget of truth that there is a really interesting discovery that is being made on Mars that is really important. And then it's not about the people who are taking their time to get the story right, to consider all of the possibilities, to have conversations and interviews with the experts in this field. It is going to be the people who are going to try to get the news out as quickly as they can and flood the field. This is always the balance that happens with journalists. You want to get the story right, or do you want to get the story out quickly? We always lean on getting the story right. However, here we are producing Space Bites a day early just so we can get on top of the story. And it's not because it's the normal cycle that we normally do, but we want to try to get some sanity into this process before it all goes cuckoo bananas. So I don't know what the answer is. But we are going to not only have this very quick take, which I'm giving you today, but we are working on stories at Universe Today to analyze this. I'm going to be bringing on guests to talk about this at great length, about the search for biosignatures and what this means. And we will be tracking this as we go over the coming months and years. Not only that, but also what's the state of the Mars sample return missions. So I promise you, I will give you the best possible journalism that I can for this story and all the stories that we do, that we're covering on Universe Today, and that we're all fascinated about. There's a lot to do. There's a lot to unpack, and we're up for the job. So we'll see you next week, I'm sure, with a bunch of updates.